Okay, so this is going to be a video on how to solve the 3x3x4 cuboid. I've gone through all the strategies in a previous video, so if you didn't watch that previous video and you're not familiar with the strategies for this, I would strongly suggest going back and watching that video first. I'm going to assume that you have somewhat of a knowledge now of those cuboid strategies. I'm still going to tell you what I'm doing as I go through it, but I want to make sure that you have some kind of a decent knowledge base before we do it. So one of the things about this cuboid, this 3x3x4, is that the top, the middle, the middle lower, I guess, and then the lower, these can all rotate in 90-degree turns. So I can rotate this top piece 90 degrees, and then I can still do something else with it. The sides and the back, the way I'm holding this with the 3x3 on top and the 3x3 on the bottom, and the four sides on the lateral faces here, the front cannot rotate 90. Well, it can rotate 90 degrees, as I said in the other video, but you can't do anything with it here. You're locked because it's an even number of pieces here and an odd number of pieces here. So in order to do anything with this, it's going to have to rotate 180 degrees, and then I can go ahead and do something else with it. So that is one of the basics that we're going to need. Let me slide these back because it's kind of getting in my way here. Alright, so again, so the idea is we're going to go ahead and scramble this thing. It is not a shapeshifter, so it's going to stay in the cuboid form the whole time, and I think this is a good basic video for anybody trying to learn cuboid strategies. Again, I've run through all the algorithms that we're going to need to solve this thing. The rest of the solve is going to be a relatively intuitive, something you should probably know how to do some basic stuff from a 3x3 first. So we're going to go ahead and scramble this thing up. Okay, I think this is a pretty good scramble. Yeah, it's not too bad. Alright, so in order to solve the 3x3x4, you kind of do go layer by layer. However, this is not like the 3x3 and the fact that you go with the bottom layer and then move your way up, at least not the way I do it. There might be a way to do that. It's not the way I solve it. What I like to do is I like to try and kind of fix the centers first. So I like to try and get this whole row right here, these whole two rows, completely fixed, and then I'll move to the top and the bottom. So the way I do it, and you do have to know something about the orientation, because the fact that there is no exact centerpiece here isn't going to help us to figure out what piece goes where. The centerpieces are on the top and bottom. We know that this bottom has to be white. Okay, that can't be anything else. We know that this top has to be yellow, because that's the centerpiece. Those aren't going to change. But we need to figure out the centers here. So you do have to understand some basic cuboid, cube color orientation. If your cube is in the basic orientation, like most of them are, the way I always do it is I understand that red, white, and blue have to be in a clockwise fashion. So if I look at this, I'm going to solve this layer right here. I'm going to turn it back over. This is going to be my red. And over here is going to have to be my white. So if this goes clockwise, like this, then red, white, that means this one needs to be blue, and right now it's orange. Okay, so I'm going to have to get a blue piece here. So the idea is, and this is a relatively easy cuboid to do because it's not going to create problems here, I'm going to find, because I don't want to move the red, I want to keep it where it is. I need to find a blue in the center up in this layer right here, and I do have one right here. Okay, if you don't, you can easily get to one. So here's the blue. I want to put it here, so all I'm really going to do is I'm going to move this layer over here, and then I'm going to turn it down. So now the blue is in the correct place. So now I've got the red, white, blue orientation that I need to have. So I should know from basic 3x3s and regular cubes, as long as this one is in the correct color scheme, and it is, the opposite of red is going to be orange. So over here, where this one is, I'm going to need to get an orange. Well, the good thing is I can see that I have an orange up here, so all I need to do is bring it over here, bring this orange over here, and then I'm going to rotate it down into place. So now on this inside bottom layer here, I've got the red, the blue, the orange opposite of red is orange, and I know that opposite of blue needs to be green. So let me go ahead and look at the other side. It is not green, but fortunately the green is right here above it. If it wasn't, you would just bring the green over, and as a matter of fact, I have another green right here, which I could have brought over if this one wasn't sitting there. But since it is, now all I have to do is rotate it down. Okay, this is the more intuitive part of the solve. So once I've got the centers of this inside lower layer here, and I call this the inside layers, this is the inside lower, this is the inside upper, and then these are my top and bottom. After I've gotten these centers in place, I need to now get the edges in place for this inside lower layer. The good news about this one is the red-green is already in place. That's really nice, so I don't have to do anything with that. I need to get, over here, I need to get the blue-red in place. And we're actually getting kind of lucky here because, well, no, actually this one's not the right one. This is a blue-red, but if I'm going to try and put this one in here, the orientation of this one is wrong. It actually needs to be so that this thing is flipped over. The red needs to be where the blue is, and the blue needs to be where the red is, so that when I flip this thing over, it's going to end up in the correct orientation. So, excuse me, I need to find the red and blue, but the other red and blue. So let's see if I can find it. Unfortunately, it's down here. So I'm not going to go with this one just yet. I could bring it up, but I'm not going to go with this one just yet. So let me move on to the next one. Let's see if I can find the blue-orange that needs to be the right way. So if I'm looking for the blue-orange piece, this piece would have to be blue. This piece right here would have to be orange. Let's see if I've got that in this upper layer. Ah, there it is. Here's the blue-orange. The blue matches with the orange here. The orange matches with the blue here. This is the correct orientation. So now what we're going to do, and this was explained in the previous video, we're going to do what would be a corner drop. We're going to basically treat these like corners. We don't have to worry about any kind of parities occurring because these are the two innermost pieces right here, so nothing is going to be a parity with flipping these pieces over here. So all I'm going to do is the corner drop with these two pieces. So I am going to use this as my top, this as my bottom for the whole thing. I'm going to kind of link these two things together for this. So the corner drop algorithm was, I want to move this one to here, which will in turn move the blue-red up to here. So the corner drop algorithm was right 180 degrees, upper, right 180 degrees, upper inverted, right 180 degrees. And as you can see, I've dropped the blue-orange into the right place. And I'm not worried about what it's doing up here right now. We're going to fix all this stuff later, so it doesn't matter if there's anything being messed up here. Alright, so now I need to move on to the green-orange. And actually, this one's perfect. That one just happens to be there. Here's the orange matched with the green matched with the orange center. So this is in the right place. So again, I'm going to do a corner drop with these two. Again, linking these top two and the bottom two together. So it's right, upper, right, upper inverted, right. And I have placed that one in the right spot. And by doing so, I brought that yellow, the orange blue out that I'm going to need to fix the last piece, which is over here. Oh, nope, I need blue-red. Oh, it just happens to be here. We've gotten quite lucky with this. It would have to be in this upper layer right here. If it's not, actually, no, it's going to have to be. There's no other place it could be because it couldn't actually be sitting here in the wrong way, in the wrong direction. At least I don't think it could. No, it couldn't. Not that piece. You could have the other blue-red, which just means it's not the right one. Either way, this one has to be up in this layer. So even if it was over here, you could move it to the right spot. So red, blue, blue, red. Again, once again, we're going to do the corner drop algorithm, which is right, upper inverted, right. And now what you can see is I've got the lower inside layer completely finished right here. Alright, so now we're going to move to the upper inside layer. And the first thing you want to look for, and I actually do have it here, is you want to look for two edge pieces that have, two corner pieces which have the same color here. I've heard them, some other people say it, I've heard them called headlights. But what you're looking for is these two to have the same color. As you can see here, blue and red are not the same color, so that wouldn't work. But these two orange ones are. If you have that, now you don't have to line it up over the orange. I've kind of gotten in the habit of doing that just so I can see it. But if you have that, what you do is you keep those on your left. I don't think I actually mentioned that in my other video, but this is what you're going to do. You keep these on your left because really these are already in place. So as you can see, the orange-green is here, the orange-blue is here. These are in place. I need to swap these two edges. Now, we did go through this algorithm in my other video. So again, it's the inside layer, it's the inside upper layer, so I don't really care what happens with this. So I'm going to kind of link these two layers, and I'm going to link these two layers right here. So the algorithm was, excuse me, the algorithm to swap these two corner pieces right here was right, upper inverted, right, upper inverted, lower inverted, I'm sorry, lower, right, upper inverted, right, upper, right. And what you can see is that while it did mess this up, now I have all of these headlights or corner pieces in place. So I can actually go ahead and fix that. Now I've got the reds in place, the blues in place, the oranges, and the greens. Now I have to worry about the centers. So what I've got is I've got a red here that obviously needs to go on the other side because that's where the orange is. Oh, perfect. And the orange is right here. So really what I need to do is I'm going to have to do this twice. I'm going to have to do two opposite edge swaps. So the red needs to go on the other side where the orange is. The orange needs to come here where the red is. And that means that the green and the blue are opposites, and they're going to have to go there too. Once again, I'm going to link these top two pieces. The good thing is I don't have to worry about the lower pieces in this case. I'm just going to link these top two because I only care what happens here. I don't care about what happens in the top yet. Now this one is going to create the parity here. It's going to flip these bars right here. Actually, I take that back. I don't think that it is, and that's because these two bars are connected. So I don't think that that's going to happen. Let's just try it and see. I can't remember off the top of my head here. So if I do the upper opposite edge swap from these two, this is the easiest parity. It's right, upper twice, right, upper twice, right, upper twice. Yeah, there's no parity here because of the location. It would have to be on the uppers to create parity. But what you can see is the orange is now here and the red is now here. So all I have to do is turn this over this way, and the green's here, the blue's on the opposite. I'm going to do exactly the same thing, and then my two inner layers are going to be completely done. So it's right twice, upper twice, right twice, upper twice, right twice. And then I can fix the top by doing a last upper twice. And the inside two layers are completely fixed. So now we need to move on to the top and the bottom. So what I need to do, and this is where the basic strategy of 3x3s comes into play, once we've done this, I now need to try and get the cross. And it doesn't really matter which cross you decide to try and get. You need to either get the yellow cross or the white cross, but you do have to have the cross in the correct orientation of the centers. So I can see, I'm going to try and get the white cross here. I can see that the white orange is here, but the orange side is over here. So I'm going to go ahead and line that up. I'm going to check my other two white ones to see if they're in the right place. So this is white red, but that's not supposed to be where the blue is. This is white blue. That's not supposed to be where the where the red is. So I'm going to have to get these into the correct place. Well, that means that the other white piece is up here, which is the white green. And really, it's supposed to go here. This one didn't actually work out, so let me see if I can match up. What happens if I match up the white and blue? I think I'd actually rather do it this way. I've actually only got one in the right place now, but it's the white and blue. The white red is here, but obviously it should be orange. The white orange is here, obviously it should be green. The white and green is right above where it's supposed to go. So actually what I'm going to do is I'm going to do it this way. This makes the most sense to me. I'm going to go ahead and place the white-green into this spot. And the way we're going to do that is literally we are just going to drop this down into its spot. But when I do that, let's put that back up for a second. I'm going to do this from the other perspective. I'm going to move this up to the top. That's probably easier to see. So it's the same idea though. I'm going to take this white green and I'm going to move it up to the top. But when I do that, I've messed with this and I've created this parity, and I don't want that. So I'm going to move the one with the yellow piece over so I can rotate this back, because the yellow piece doesn't belong up here anyway. Now, I don't believe that I've completely fixed this thing. Let's see, I've got orange here and red here. But I've got this green and this blue in the wrong spot. So what I can very easily do from here is I can take this blue one down to the bottom, and I can take this green one down to the bottom, and I can rotate this bottom now 180 degrees so that I can bring the green one back up into the right spot, fixing my centers, and then I can bring the blue one back up to the right spot, fixing these centers. Hopefully that was a relatively intuitive move. I'm not sure if it will be for you or not, but if not, I think you can figure it out just by looking at it. If you have some of these in the wrong spot, it's just going to be about playing with them so that you make sure you rotate and then rotate back so that you're not creating a parity in the middle here. So now the next thing is I need to fix these corners. Now they don't have to be in the right spot right now because we have algorithms to fix this. But I need to place these corners. I have one that's in the right place. There's a white up here. I need the other three whites. So we're going to basically do a corner drop. All I'm going to do is I'm going to line up one of the yellow corners that needs to not be there in my closest to me on my right, and I'm going to find any white corner on the bottom. So I've got one here, here, and here. It doesn't matter which one I pull up there at this time. I'm just going to put this corner up here with this one. So we're going to do the corner drop. Now the corner drop does create parity on the inside layers. If it was just a corner between these two, because there's no inside layer, you're not going to have a parity in between here. But since I've got these two layers inside here, when I rotate this, it's going to rotate an odd number of times. It will create this bar flip, but I'll show you how to fix that in a second. So I'm going to do the corner drop from here to here, and this is going to bring this one up to here. And the corner drop is right, upper, right, upper inverted, right. And again, I move this 3 times, which is why this bar is flipped over now. So the whole bar here should be the other way around. But I did bring the white one up. So if I keep this parity on my right hand side where these bars are flipped, and I move this next yellow piece in, I'm going to find another white one, which is right here, to move it up to here. So we're going to do the corner drop again. And in doing that, it's going to fix the parity. So it'll be right, upper inverted, right. And it's fixed the parity. And now I have 3 of the corners in. I'm going to need to put one more in. And yes, this is going to create a parity, and I'll show you what to do with that in a minute. Because I'm going to keep leaving the parity on my right hand side, and it's going to go in and out of fixing itself. And then we'll have to see at the end if we actually have to try and fix the parity, if there's nothing else we can do. So let's do one more corner drop. Here's the yellow. Here's the white, line it up right underneath, and we're going to do right, upper inverted, right. So now I have the entire top face fixed. It's not all in the right orientation, as you can see, but the entire top face is now white, and we needed that. And it did create this parity over here. I'm going to hold the parity on my right hand side so that I don't create any additional parities, because that just creates extra stuff to do at the end. So what I can see is I do have this solid bar of red right here, which means I have the 2 corner pieces the same color, which means these 2 are out of place. As you can tell, they don't match. So I'm going to hold the solid bar on my left, and I'm going to swap these 2 corners, which will then fix all of the corners. It might mess up the centers, but that's okay, because they're still all going to be white. We'll fix the centers at the end. The centers are the last thing that we fix on one of these cuboids. So we're going to swap these 2 corners. The corner swap does not give you parity, or in this case, it won't fix the parity, so that because it's an even number of turns of the right side. So the corner swap was right, upper inverted, right, upper inverted, lower, although it doesn't matter that much on this one because I haven't done anything with this, right, upper inverted, right, got the yellow bar now, upper, right. And actually what I've done is I did get my 2 blues. I actually got the whole bar here. I have 2 reds, 2 greens, and 2 oranges. So I actually switched the bar from being all red to all blue, and that's okay. It could have been none of them. But I do have all of the corners fixed. So I'm going to go ahead and put the blue on its side for right now, just so I can take a look at this. So what I need to do is this green needs to go here, the orange needs to go back here, and the red needs to come over to here. So I can do this in one of 2 ways. I'm either going to do an opposite edge swap first, or I'm going to do an adjacent edge swap. And one way or the other, we're going to have to do this twice. So we're going to have to do 2 different edge swaps. So what I'm going to do is I'm going to go ahead and do the opposite edge swap first. I'm going to swap this red-white with this green and white right here. And in doing so, this one creates parity, or in this case, it will fix the parity. Unfortunately, I'm going to also have to do an adjacent edge swap, which is going to create the parity again. But again, we're going to leave it here on the right-hand side so we can see what to do with it. The opposite edge swap is the easiest one. Now we're only dealing with the upper layer, but it's right, upper twice, right, upper twice, right. And then now you can see that I've got the entire red, the entire blue, but I've now got the green and the orange out of place, and my parity was fixed. So now I don't have to hold that orientation anymore. What I do need to do now is this adjacent edge swap. So I need to get the white-orange to here and the white-green over to here. This one will once again create parity, and to do this one, you keep the things that need to be fixed, the edges in front and to the right. So this is going to be right, upper, right, upper, right, upper twice, right, upper twice, right, upper, right, upper inverted, right. Now the entire top layer is fixed. And it did, like we said, it created this parity. It flipped these 2 bars right here because of the fact that we turned this right side an odd number of times. So now that we're done with this piece, we're going to go ahead and flip this thing over. Because you do have the parity, hold it on the right-hand side. It's just going to be easier if you keep it here and you don't create any additional parities. So we're now basically going to do exactly the same thing with this layer. We're going to look to find headlights, or 2, yeah, here we go, 2 red pieces, or it could have been any 2 colors, on the corners that are the same. So because I don't want to mess with this, although this one won't mess anything up, I'm just in the habit of it. I'm going to put those on my left. I need to switch these 2 corners right here, and I'll have all the corners in place. It will not do anything to this parity. It's not going to affect it. So I could have done this from this position and it won't make anything different. I'm just in the habit of keeping the parity on the right. So I'm going to take these 2 and keep them on the left, and I'm going to switch these 2. And that was right, upper, right, upper inverted, right, upper inverted, lower. It is really important to do this part now because of the fact that you actually had it solved, so let's keep it that way. Right, upper inverted, right. Now I've got the solid white bar, so bring it back, upper, and then right. And wow, okay, we got really lucky there. I can fix the bottom, and as it turns out, the top is completely fixed. That doesn't usually happen. Usually you have to do something with the centers. But that's okay, because this actually gives me an opportunity to show you that this is what happens if you get through the entire solve and you get this parity left over. We didn't do enough of the switches to fix this parity. So there is a way, if you end up with this, and this is usually the last thing I would do on one of these if you end up with this parity. And by the way, if you had to fix your edges up here and you had to do either an opposite swap or an adjacent swap, you would do the same thing that we did on the other side in order to do that. So now I need to fix this parity. And again, this algorithm is in the previous video, so we'll run through it with this. But the algorithm for this basically takes these 2 bars and flips them over without affecting anything else. And this is a really big algorithm in all cuboid strategy that you're going to need to know regardless, so it's a good thing to know this one. And you do it enough, you just kind of get used to it. So it's going to be both tops 180 degrees. Right. Oh, I should go back. make sure that you have your parity on the left and the right side. So it's basically the two bars that are flipped, they're sitting right in front of you. Okay, so it's both uppers 180 degrees. Right, 180. Front, 180, because that's all you can move them anyway. Both uppers 180 degrees. Top, 180 degrees. And you can see the two reds are matched up now. Front, 180 degrees. Now these bars are matched up. The only thing I'm missing is this one, so it's right 180 degrees. And then to fix the entire cube, both tops 180 degrees. And now the whole thing is fixed. So I didn't run into every possible thing there, but I came close. I think I hit every one of our algorithms that we needed to, at least at one point or another. So there you have it. That is the solve for the 3x3x4. Hopefully you found the video educational. Again, if you hadn't already watched the previous one and you're not sure what these algorithms are and what they do, go ahead and go back to the previous video. Go ahead and leave a comment if there's something that you feel like I've missed or something doesn't make any sense to you and you'd like me to go into it further. And I hope you enjoyed it.